All right, so this is section 5.2, video 2 for Math 146. Um, so we've established at the very end of the last video that there's a possibility of having no triangle, one triangle, or two triangles, but we didn't talk about how you figure that out. So if you kind of look at the one where it says no triangle, and I kind of showed you and I mentioned that the A value has to at least reach down to where that C side would be in order for us to actually be able to form a triangle. In order for us to do that, again, it has to be able to, at the very least, form a right angle. And what this really comes down to is, do you understand how to measure the height of a triangle? Well, the height of a triangle is going to be measured from one vertex perpendicular to the other side, to its opposite side, which is going to form a right triangle, or excuse me, a right angle within the triangle. So for example, if I use the one on the right-hand side where it's got the one triangle, if I wanted to measure the height is measured here, and that would form a perpendicular here. We don't measure a height at a slanted angle. That just doesn't make any sense. So the height is the important part about this. So if I want to have something, or excuse me, if I want to figure out that I have no triangle, basically the height of the triangle, which is going to be that A value, would actually have to not be long enough. The question is, how do we find the height? Well, this is where the trig stuff is going to come in. So if we were to just look at a triangle that maybe doesn't have enough length to it. We'll call that A, that's B, here's capital A, on the other side is C. The height, it'd actually be from here, let me use a different color, be from here down to here. That would be the measurement of the height. And so how do we find that height? Well, it's all based upon, again, it's all based upon trig. I know something about angle A, I know something about side A, which is opposite of it, and I know something about side B, which would be the hypotenuse. And if you understand that this is SOHCAHTOA based, opposite and hypotenuse is sine. So I know that sine of angle A is going to equal lowercase a over lowercase b. But lowercase a is what actually would represent that side, which would have to be the height. So if I were to multiply both sides of this by lowercase b, I would get that lowercase a is b times the sine of a. Well, in order for us to have a triangle, because this would really represent your height, a has to be greater than that height in order to actually have a triangle, greater than or equal to, I should say, to have a triangle. So this is the criteria. If your A value is less than the height, which is represented by B sine A. So just like here, this height, I mean that A value is less than the height, then there's no triangle. And this is the formula that you would use. So if A is less than B sine of capital A, we have no triangle. The only really nice thing about this is that you're done. So if you take B sine A and that happens to be, and your A value is less than that, you're done. There's nothing else to solve because there's no triangle. If A equals, if A equals B sine of A, well, that means it is exactly the height, which means this will form one right triangle. Okay, and then the other possibilities where we kind of had the ambiguous case. Sorry, we got two other possibilities. Sorry, because this is all really part of the same thing here. We could have one triangle like we have up here, and I was very careful to draw this way. What you should notice, in order to have exactly one triangle, like the one where it says that, this A value has to be greater than or equal to that B value. If that's the case, you will have one triangle. So up here, if A is greater than or equal to B, you will have one triangle. And again, the no triangle thing is that A would have to be less than B sine of A. That would give you no triangle. And then in order to have two triangles, two criteria have to be met. And again, I was kind of careful to do this. The A value here actually has to be less than B. So that side has to be shorter than B. But it also has to be greater than B sine of A. It has to be greater than the height. Because again, if it's less than the height, there's no triangle. Doesn't matter for the rest of it. So those are your criteria. So that's the first things that we should look for when we're going to solve any of these. And again, this is a circumstance where they give you two sides and an angle opposite of one of those sides. So now let's do some examples and see how this works. The ones that take the longest are the two triangle ones because of the fact that, well, there's two triangles. So you really have to figure out both of them. Let's do one where we show it just doesn't work at all. You just can't possibly get a triangle out of it. So our first example, let's extend this a little bit, is going to tell us that side A is 2, side C is 1, and angle C is 50. And you might look at that right away and say, wait a minute, you said we've got to have B. Don't worry about the lettering. It's all going to go in the same spots. So basically, I would go ahead and draw this just the same way we did before. So you've got some kind of a thing right here. C is the one that's got the opposite angle and the opposite side. So we're going to say that this is angle C. Side C is over here. And then A is this one, which is 2. And side C, they tell us, is 1. So in order for us to figure out whether we actually have a triangle, that C value right there, the lowercase c value, would have to be bigger than or equal to, in this case, A sine of 50. So 1 would have to be, actually, I'm not going to write it like that. 1 would have to be bigger than or equal to A sine of 50. So let's figure out what the height of this thing is. We want to find the height, which is, let's not write it right there. The height is 2 sine of 50. And again, that comes from, if I were to draw the height, that would be right there. That comes from SOHCAHTOA. So then you could type in what is 2 sine of 50, and the height approximated would be 1.53. And since that C value is less than the height, C is less than 1.53, there is no triangle. Because in order for me to have a triangle, the height at least has to be at that 1.53 length. So we have no triangle. All right, by far the easiest one to do as far as that's concerned, because again, there's nothing else for us to do here. All right, now let's try one that ends up having just one solution. So the information that might be given would be that A equals 3, B equals 2, and angle A is 40 degrees. So again, if we just kind of sketch what that might look like, and I know now we've actually got the A, B, and C. So here's B. They're telling us A is 3, which is longer than B, which is really the only criteria that we needed to find one triangle. And then you've got this C over here, which is whatever it is. We'll have to figure that out. They gave us angle A is 40 degrees. And again, the only criteria that we had to worry about here was that A is greater than B, right? That was the criteria that we needed for having one triangle. A is, well, technically greater than or equal to. And that is the case because 3 is definitely bigger than or equal to 2. So we have one triangle. So now we can figure out how to solve for all these pieces. So now let's actually use this law of sines. So we're going to have the sine of 40 divided by its opposite side, 3. Now the only one that I have another known value for is b right now, so let's label that as b. That's capital C. So the sine of capital B over 2. And now we can go ahead and solve for that angle. So again, cross multiplication, we'll have 2 sine of 40 equals 3 sine of B. And remember, I'm solving for the angle now, so we have to divide both sides by 3. So we get 2 sine of 40 divided by 3 is equal to the sine of B. And in order to now actually solve for B, we're going to have to use inverse sine. So we would take the inverse sine of both sides of this, and we would get the inverse sine of 2 sine of 40 divided by 3 equals B. All right, so now the only thing you have to be careful of here is because, again, what's going to happen when you plug this in your calculator is you're going to get the acute angle out of this. It's going to give you the first quadrant equivalency of this. So B is going to be approximately equal to, let's see, I got to plug it in the calculator real quick, 25.4 degrees. So that's going to be your approximation for B. And remember that sine, while the inverse sine has restricted itself between the first and second quadrant, could actually still be positive in the second quadrant. So it could result in an obtuse angle. But if you take 180 and subtract 25.4 to see what its obtuse angle would be, it would be like 154.6, I think, or 100, yeah, something like that. 154.6 plus the angle of 40 that's already there is already over 180 degrees, so it's not even possible to use that because that wouldn't leave anything for C to have a negative angle for C, which is not possible. So in this case, it has to be this acute angle. You just have to be careful in the fact that you could possibly get an obtuse angle, so you have to check for that. So let's see, so far we have found angle B. Excuse me. And now we need to find angle C and side C. Well, I don't have either one of the pieces of information, but now that I have a second angle, I can find angle C just by taking the angles that I know and taking them away from 180. So we know that angle C, capital C here, is going to be 180 minus the sum of the two angles that I have, which is 40 and 25.4, so that would be 65.4. So angle C is going to be 114.6. And that one is an obtuse angle. So now I've got two parts of this triangle. The only thing that I have left to do is solve for side C, which again, we can use the law of sines to do. So let's see, we're going to start off with the pieces that we know, which is going to be the A value. So we'll take sine of 40 and divide it by 3. And we'll set this equal to the sine of angle C, which is 114.6, and divide it by lowercase c in order to find the side. Cross multiply. And then divide by sine of 40. and we get an approximated value of 4.24. And again, double check that this makes sense. Well, if C is our largest angle, and it is 114.6, it should also have the longest side, which it does, 4.24. The other two sides are 2 and 3, so that is definitely the longest one. So all the information that we have here seems like it should match. We have solved that one, that one triangle that was being able to be formed. All right, the last example is going to be where it's the ambiguous case. It's the one where you could have two potential triangles, or you will have two triangles that can form out of this. So let's go ahead and write up the criteria here for this one. So example 3 here. This time we are given that A equals 6, B equals 8, and angle A is 35 degrees. So the criteria that we had to use, first of all, does it even form a triangle? Well, you could certainly do that by doing B sine of A. So we're going to make sure that the height is going to, A is going to be bigger than the height. So B sine of A. And just to double check, you get approximately 4.59 for the height, and A is bigger than 4.59, so A is bigger than your height. So we know we have at least one triangle. And how do we know that we've got two triangles? And that is because B is going to be longer than A, or A is less than B, however you want to say that. So A is less than B. So we know we have two triangles out of this. So again, we can kind of sketch it. So here's A, I'm sorry, that's B, that's 8. Here's A over here, which they said is 6. And then here's C. But remember, we're going to have two triangles, and that's because A could also be over here and be 6, because these are the same. So you can see how you would have two triangles out of this. We've got the big triangle, which is this one in red. Or if you were to swing A over, then you would have this little one right here, which would be kind of highlighted in blue. So you would have two triangles, and technically you have a third triangle, but that's not actually formed by A and B. It's formed by having two A's and then some kind of a side, but we're not worried about that one. We're worried about the one that's formed by A and B, and then the angle in between here, they said was 35 degrees. So basically we're going to have to solve two triangles. So let's go ahead and get started on that. So we know that, let's see, the pieces that are matching are the A, so we'll start off there. So sine of 35 divided by 6 is going to equal, and because we have B as our other piece, we'll do the sine of B divided by 8. Cross multiply, 8 sine of 35 equals 6 sine of B. And then solving for B, divide by 6. 8 sine of 35 divided by 6 is the sine of B. And then we'll have to take the inverse sine. So inverse sine of 8 sine of 35 divided by 6 is going to equal angle B. Now, look up here at the drawing. Angle B could be this angle, or it could be this angle. So in this case, we actually do have two angles. One will be obtuse, the other will be acute. So we're pretty much going to do both of these at the same time as far as solving the triangle, but we'll label this over here as, oops, not tringle, triangle 1 and triangle 2. We got two different parts. So when you go ahead and do the inverse sine of the expression there to find b, we're going to get the first b value, and this is what your calculator will give you because it'll give you the acute one, is 49.9 degrees. So we'll put that up here for triangle 1, 49.9 degrees. Then if you want to find the other triangle, which is going to be the obtuse angle, b would be take 180 and subtract 49.9, you're going to get 130.1 degrees. So that's the obtuse one. That's the bigger one. Now that we have that, we can use this information to find the C stuff. So from the original B values, if I want to find C, I know that I'm basically going to add the two angles that I know. In the first triangle, it's 49.9 and 35. I'm going to add those together, and then we're going to subtract that from 180. So the first one is going to give us, let's see, plug this into the calculator, 95.1 degrees. And in the second case, let's see, 130.1 plus 35, and we'll take that away from 180. That's going to give you 14.9 degrees. So the C value of the bigger triangle, because that's going to be this little angle right, oops, I had that wrong. Sorry, I labeled this completely wrong. Hopefully you caught my mistake. This is actually going to be the C values right here. That's the bigger C, that's the little c. Over here is B, or over here is B. So the obtuse one for B, or triangle 2, comes from this one. Triangle 1 comes from that one. I apologize, I labeled those completely wrong. And the opposite of C is going to be the top ones. Hopefully those make sense now when you look at them. The smaller C is the 14.9, the larger C is the 95.1, so it's an obtuse angle. But now that we have that, we can actually find lowercase c. And each one of them is going to be set up the same, it's just going to give you a different result. So to find lowercase c on the triangle 1, once again, we're going to start off with the information that was given, which was the A stuff. So we're going to do sine of 35 divided by 6. And now that we know the angle, we'll do sine of 95.1 and divide that by lowercase c. I'm not going to write out the whole cross multiply and divide thing. I think you probably have that by now. You would find here that lowercase c is going to be about 10.42. And again, triangle 1 is going to be the larger triangle. So 10.42 being the length of C makes sense. It's quite long. It should be the longest side. When you do it with the other one, C should be shorter because it's going to be a smaller angle. So let's see that that works. So you'd set it up the same way. Sine of 35 divided by 6 equals, now let's see, that would be sine of 14.9 divided by little c. So little c here in this case is going to equal 2.69. And that is definitely the smallest of the sides, and that should make sense because if you look at this piece right here, that is the smallest if you're using that part as C. All right, so there are all the different cases that you can come up with in order to solve right triangles. In the next video, again, we're going, not right triangles, to solve triangles. I apologize again. In the next video for 5.3, we're going to do the law of cosines. It's a little bit more straightforward, although the formula is a little bit longer to deal with, but there are no special or ambiguous cases in this case. It's just going to be, this is what it is. Let's solve it.